a study about variation in G due to shape of Earth. Now, as you know that the shape of Earth is not a perfect sphere, so it is actually considered as a flattened at the poles and bulges out at the equator. So, in this case, we would be considering that the equilateral radius of the Earth is actually about 21 km greater than the polar radius. So in this case, we would be writing the G value for equator. So that will be GE. So GE will be GM RE square. Now I would be writing at poles. So it will be GP GM RP whole square. So this is my first and this is my second equation. The first equation is at equator and the second equation is at poles. So now from equation 1 and 2 I can compare the value of GE and GP. So if I write this GM over RE square and GM over RP square. So the leftover values will be RP square and RE square. Now as you know that the R equator is greater than RP, and therefore we can write that GP is greater than GE, and it was concluded that the GP value is equal to GE plus 0.018 meter per second square. Therefore, we say that the weight of the body increases as it is taken from equator to the pole. And we can also conclude that the value of G is least at the equator and maximum at the poles. It means the value of acceleration due to gravity increases as we go from equator to the poles. So this is about variation in G due to shape of Earth. Now the second part is variation in G with height. So now as you can see we have a surface of Earth here which shows the G value here. This is G and this is G dash where we have another object which is at height h. So first of all I would be writing acceleration due to gravity at the surface of Earth. So it can be written as G Gm r square. This is on the surface of Earth. And when we talk about acceleration due to gravity at height from the surface of Earth, it will be G dash equal Gm will be same. Now the r, the distance between two objects has been increased to r plus h whole square. Now we need to compare these two equations again. So G over G dash equal to r plus h whole square over r square. Now we can write this equation in terms of G dash. So G dash will be or you can write it as this G r square r plus h whole square. Now I would be taking r square common from these two terms, the numerator and the denominator. So now we are left with 1 plus h over r whole square. Now if we consider that the h over r is very small as compared to 1, so we can neglect that value and we can solve this by equation by binomial theorem. So when we solve this we will get answer as, let me rub this. This will be written as G1 plus h over r raised to power minus 2. Now we can solve this value by using binomial theorem because we are considering that h over r is very small as compared to 1. So we need to expand the right side with, with the help of binomial theorem here. So it will be 1 and minus 2 will come over here. So minus 2h r. So g dash it will be g dash equal g bracket 1 minus 2h over r. So it is due to the reason that the value of acceleration due to gravity is lesser at mountains than in plains. So this is the reason behind it.